Saahil Jain, CTO of U.com, watches billions of agent requests from DuckDuckGo, Harvey, and companies like that. He still thinks people are building agents the 2024 style. The difference is, in 2024, you had a lot of orchestration around an agent, and that's how you built a production agent. And now that the models have gotten better, he believes that this can be stripped away. To prove it, he tried it on his own agent, the research agent. That is the industry benchmark, the standard. He is going to talk about how he did it and how to build an agent the 2026 style. Welcome, Sahil, to the show. Let's start with the research ARI, right? Your current deep research agent, when you built it, you had a lot of orchestration around it. Once the models matured, you started dialing it down. How was that? How did you figure out this was the right time to dial it down?
Yeah, and maybe I should provide a little bit of context about kind of, what this product was and what we've been working on. But yeah, so my name is Sahil. I'm currently working at U.com. So I'm the CTO of this company called U.com. We're focused on building the best search infrastructure for agents. And what that means is we're really focused on building, powerful information retrieval tools. And we really view ourselves as a search lab that's focused on search, across various levels, from lower orchestration search to higher orchestration search and research. And what you're referring to is a product that we worked on called ARI, our Advanced Research and Insights Intelligence Agent. And ARI actually was one of our deep research agents that we launched that did achieve state of the art on various deep research benchmarks at the time. And if you look at our history, we started in 2020, and when we started by focusing on building a search engine that would compete with Google. And then as we evolved and as AI became more basically improved, we started using and building experiences that leveraged large language models. And when we did this, we actually ended up connecting search to LLMs and AI. And in this context, we actually then started working on things like deep research, where we wanted to use search with AI models. And this is where we developed ARI. At this point, we've actually realized that what we really focus on is the search layer and the information retrieval layer, and exposing that to enterprises as an API so we can power their businesses. And we power, over 1 billion queries per month, using some of these information retrieval techniques. And specifically on the concept of ARI, what we learned was at the time, and this was around 2023, 2024, when we were building a lot of these agents, we had to really work on a very different type of orchestration. We had to kind of set up these very complicated flows, guardrails, post-processing logic, pre-processing logic, and really guide the agent to get really good results. And what we realized is as the models got better, year after year, we were actually able to get better and better performance by simplifying our stack. And that's just more of a macro trend that we're noticing, which is, when people are building agents, oftentimes, the orchestration layer needs to be designed very thoughtfully for it to stand the test of time.
So when you started building this agents, at the end of the day, you wanted it to be as autonomous as possible, avoiding orchestration around it, and you took that step to do it, right? What what was the main signal or the symptom that you saw that what now it's working?
Yeah. So, I mean, when we were building, when building autonomous agents, a lot of what we do is guided by evals. So I think evals is something that obviously has been a hot topic for many years now. So it's no secret. But we invested a lot in evals to really guide the development of the product and confirm that it's working. And then once you have evals, you kind of measure your product along different dimensions. So cost, accuracy, latency, uh, and there's other attributes as well, but those are the main three that we focused on. And we got to some optimal combination that we thought was good for our users at the time. And that was when we thought that, okay, this is working now. And then once you have those evals and those guardrails, you can then start changing the experience a little bit more responsibly. And that's when we realized that we can continue to simplify, and the behavior of these newer LLMs is very different than the behavior of the LLMs, 1 or 2 years ago. And we find that many folks are still developing with the mindset of, LLMs, at their performance level 2 years ago, as opposed to their performance right now.
The 2024 LLM versus 2026 LLM.
Yeah. So of course we all know that it's gotten a lot better, but there's also implications, and we have to extrapolate what that means for 2028 LLMs, 2027 LLMs. And our philosophy in general is that, there's going to be two there's a couple different components when it comes to building agents. When building agents, you have what we call the engine. So this is the core LM, the foundation model, which are becoming better and better. So these foundation models are becoming better and better at long horizon tasks. And then you have tools. So tools are the services that are actually powering these foundation models. And then you have these harnesses and these orchestration layers that are coordinating how the tools and the foundation models work. Our prediction is that what is going to become really important is the foundation models themselves. We already know these are important. It's the underlying engine and the tools. The tools allow the foundation models to go further. And we believe that focusing on the right tools is really important. And this is reflected in the bet that our company is making, where we're focusing on specifically the search tool.
Now that the tools and the orchestration, in fact, it has only three components in your mind, right? So the model, the tools, and the orchestration. Now, if you look at it, the orchestration is almost dialed down since the models are getting better. Now, what should the teams focus on? Is it the data and the tools? What is a thing that's going to survive these model improvements?
Yeah, it's a really good question. And I think this is actually changing day to day, and there's different philosophies here. But as you mentioned, in the framework that we're talking about right now, I've just defined three different terms. One being kind of the foundation model itself, the tools, and then I'll call it the harness or the orchestration layer. Our philosophy is that the foundation model is really important, but there are very few companies that are focused on building the best foundation models. Um, and if you're developing it or you're deciding to work on it, you have to be very intentional. That said, a lot is changing with open source. So now that open source models are becoming very efficient and in some cases, close to the performance of some of the frontier models from some of the bigger labs, the dynamics are changing a little bit. But what we think is that it's really important to focus on the tools. So the tools combined with some of these foundation models are where you can really differentiate in terms of performance. And then in terms of the orchestration layer, there's two philosophies here. One philosophy is that the models themselves will work best with harnesses designed by those companies. So the idea being that you can train your model end-to-end to work really well with the harness. This is kind of the idea behind Cloud Code, for example, being one of the best products because the Anthropic models can be fine-tuned and trained end-to-end with Anthropic's Cloud Code harness. On the other end of the spectrum, there are companies that are emerging that are making the opposite bet. They're basically making the bet that with open source models rising, a lot of the orchestration layers is essentially routing and using multiple models together and not overfitting a harness or an orchestration layer to one specific model. One of our customers, for example, Factory, this is kind of the direction that they're going. And there's other companies as well that are really leaning into, using many different models and specifically relying on open source to reduce costs and have better total cost of ownership in terms of their products. So that's kind of what we see. So I think that if people are focusing on orchestration right now, what they generally tend to focus on is using and leveraging a variety of models. This was not possible also in 2024. At that point in time, the open source models were significantly worse than some of the proprietary models. And that's another thing that's changed when it comes to orchestration. So what we think it's important to focus on is one, the tools that you're using, and then making sure that the tools that you're using match the foundation models that you're using. Certain foundation models can only work with certain tools. I'll give you an example. When it comes to search, when you're using some of the bigger models from OpenAI, Anthropic, they have bundled web search with their models. And if you want to then use open source models, with Anthropic models, you actually need an independent web search provider, and that's where we come in. We allow essentially the ability to use different models, and we open up the harness and the orchestration layer a little bit.
Got it. Got it. So, Sahil, what specifically in these models, what improvement specifically is asking for this dial down
And when you say dial down, what do you mean exactly?
of the harness?
Yeah, and maybe I should define what we mean when we say dial down the harness. What we mean there is, I think the harness is still important. So there's a lot of companies that, have invested a lot in their harnesses and the way in which they use foundation models with tools. That said, I do think that more and more of the value is not necessarily going to accrue to the harness and the orchestration layer, but will accrue to the tools that you use with the models that you use and the feedback loop. So I do think, now this pendulum is shifting where on the foundation model side, if you have an open source model, you can fine tune and reduce costs. That is value. If there is true cost savings and latency savings, et cetera. On the orchestration side, because the models are getting much better at longer horizon planning, they don't need a lot of the guardrails and a lot of the instructions that they needed in the past. As you may have remember, about 2 years ago, many people predicted that this role of a prompt engineer would become a formal role. If I look at any job posting right now, I don't see a single role or job offering for a prompt engineer anymore. There were prompt engineering roles back in the day. So what happened over there? What happened is that the models got a lot better to the point where you don't necessarily need to prompt engineer them the same way. And the problem actually shifts back to the model layer and back to the tool layer, and much less to the orchestration layer in that sense.
Got it. So you've said that a good agent, what separates a good agent is really the data and the tools behind it, right? What does it look like in practice?
Yeah, so I think that when we think about good agents, when we say good, it depends a little bit on what we're talking about. There are agents that are operated by various types of companies. Many good agents, will operate in particular verticals. So they'll target a vertical like finance, law, and then really have agents that work well within those domains. I think that's the pattern that we're seeing is this verticalized approach, and then there's this horizontal approach of building agents that work across horizontals. The area in which we've seen agents pick up the most is coding. So I think we're all familiar that coding agents have really taken off this year, and there's a variety of companies that have really kind of massive ARR growth just off of coding agents. So what makes and then your question is like what makes a good agent good? And one thing that we've noticed with many of our customers, at least, that are doing really well, is they take a lot of attention to the models that they're using. But at the same time, everybody is aware in general of the same models. These are kind of your frontier models. These are the best open source models. So that's not necessarily where the advantage is. Um, but they also use really good tools. And often cases, they will have access to specialized data. So, for example, companies in the legal space that we work with, they've invested a lot in really optimizing their flows for their domain. And this often includes access to data that's, very unique to their business. And they combine it with public web data with what we're building. And they're able to then have a very unique performant experience. And then on the harness side, and that side over there, they're doing in some ways the bare minimum work to make sure that the agents do well, knowing that as the agents get better and better, you can be flexible over there and keep removing components or altering components as needed. The most important thing is having really high velocity on the orchestration and harness layer because it's constantly and dynamic. It's very dynamic. On the tool layer and the model layer, that tends to actually, that shifts a bit differently. And obviously, the model improvements inform the harness improvements and vice versa.
Clear. Now, Sahil, let's assume someone dials down on the harness. How do they measure the efficacy of it? How do they know that the agent got better and not quietly worse, right? So how do they measure it?
Yeah, and this is where it's really important to focus on proper evaluations and really, making sure that you have ways of measuring performance. And this is easier said than done. I think evaluations is something that every company that's building an agent has to some degree, but I've noticed that there's varying degrees of maturity when it comes to evals. In our case at U.com, we actually have a particular AI evals team that is really focused on just building the best AI evals. And we partner with other companies that are also really focused on evals to jointly build benchmarks and optimize our technology together. Um, yeah, and I can go into more detail there. Just curious, yeah, if you have any questions.
Yeah. So that probably is the $1 million problem today, right? What is the efficacy of it? Should we ask another agent to really measure it? How do we figure out, right? So that if someone has a solution to this problem, I think he has the next $1 trillion company already.
Yeah, I mean, I think this is an emerging area of research when it comes to evaluation. But what we've noticed on the space of evaluation is that we're still very early when it comes to proper patterns and benchmarking of agents. So one example of this is research that our team did, which we've published externally in conferences. And this is our AI evals team, where we focused on really understanding, how should we be benchmarking agents? Um, and we can take, a lot of tools that we've learned from other domains like medicine and apply them to agents as well. And an example that's very simple is when you look at benchmarks, most of the time, it's usually a single number with no confidence intervals and no variance quantified. And this is obviously not something that you would do in the peer review space. But I mean, it's okay to do in a fast moving space where there's just press releases and there's more competitive dynamics. But I wouldn't really view it as peer reviewed, scientific in nature, some of these benchmarks, nor are they maybe purporting to be either. But when we actually looked at what variance even means, so even if people were to include variance, it's actually important to understand the source of variance. So variance can come from two different sources. It can come from what we call agent inconsistency. This is the agent itself being inconsistent for the same question, or benchmark difficulty. There's different, difficulties of questions on benchmarks. And what we've realized is most people never actually report, what variance stems from the agent being inconsistent versus the benchmark, difficulty being different, or a function of benchmark difficulty. And what we realize is that, there's kind of tools you can use like interclass correlation coefficients, like ICC, that can help determine how inconsistent an agent is. And this is really important now that we're actually entering the stage of productionizing agents. We really need to understand how to properly, measure their ability to be consistent in important real world, potentially, higher stakes workflows. So this is all to say that there's a lot of research that needs to be done when it comes to evaluation. And that's just one example of an area that we dug into, but there's so much more when it comes to properly evaluating agents and making sure that they kind of enter the world responsibly.
Now, any comment on the recent agents getting out of their sandbox and probably creating a network without really prompt or even asking anything?
Yeah, it's, I guess, I mean, I don't have too much comments there other than to say that things are moving really fast. And that's why I think that, as these agents and as these models get better, we have to really think about, what actually matters. Like what should we be designing around? What should we be building? What becomes important? Sandboxing technology is actually becoming really important. So there's companies like Modal and Daytona who have built really great, sandboxing environments. So it's becoming, I think that's an example of an area that's probably going to emerge where you need to have really tight constraints in terms of the environment that agents function in, so that they can't do things that can potentially destabilize or pose security risks. So there's a lot of really interesting work happening over there in this general space. But yeah, I think my general thought over here is that this is actually a good pointer of what to build. So as these models become better, and I think security is one issue that is really important, and that's top of mind for us as well.
So basically, try to build something. The model improvements cannot really make it insignificant or irrelevant.
Yeah, I think that's the key. If you're working on something, you want to make sure that you're assuming that the models will continue to get better. And I think that's the main takeaway from your point over there, which is, at the point that they're so smart that they're, escaping their sandbox and changing the benchmark scores on Hugging Face, that that is a sign that they're becoming very intelligent. And that has huge implications in terms of what we should be focusing on when building products. And I don't think it's fully hit everybody yet. It hasn't hit me yet fully, honestly, either.
Yeah. These days, things are changing by weeks, not even by months. So it is natural that it takes time to sink in.
Yeah, exactly. We I think we're living in a very dynamic environment.
Yeah. Now, for an engineer that is shipping 2024 style agent, now I understand that you have to think about 2028, but how is it different to build a 2026 style agent?
Yeah, I mean, I think if I were to back up for a second, the way I view where we're at right now, and this is an analogy that we often use at the company, um, if we look at the self-driving space, we first built the roads, and we've had roads that we've operated on for centuries, and then we built self-driving cars that operate on these roads. In the case of a lot of these foundation models, especially in 2026, we have some of these really smart, these self-driving cars before many of the roads have been built. So this is a very different set of sequence of events compared to self-driving, this analogy. And what that means is, when you're building when you have a lot of these foundation models, the blocker is not necessarily the intelligence of the model or the self-driving car. It's actually the roads that the car can use. So to me, in 2026, it's really important to kind of truly ask yourself, is the problem that you're working on blocked by intelligence, or is it blocked by some type of road? Like, does it require a smarter self-driving car, or does it require more roads to be built? And I do think for the majority of cases right now, there's a lot of low-hanging fruit where you can just build roads that allow these self-driving cars to go further. And for us, well, the road that we're building is search. You use search as one tool or one road that allows these cars or these models, these foundation models, to go further. And I think that's something that is more of an analogy, but that's how I view a lot of the work in 2026. And I view it in two realms. So either you're working on the foundation models, or you're working on the roads that the foundation models use. And if we believe that more and more of the economy will be automated through foundation models, more and more The work that we do will be one of those two flavors. Either we're building the roads that the foundation models will use to achieve their goals, or we're working on the foundation models themselves. I think all of the stuff that's not those two categories will probably blend into, in some of those two in some shape or form.
That's a cool analogy to think about, right? Either you build the roads or you build a car, or help build a car.
Yeah.
Yeah. So what we at Sedai do is autonomously manage your cloud. So we have some strong algorithms that can take all these intuitions and convert them to reality, right? We use reinforcement learning at the end, right?
Mm.
To figure out, you know what, your thinking was right. We got all the inputs. Maybe we got 100. We will convert them into 10 actionable ones. And for those, when you take a left or a right, we don't ping the humans. It's like a self driving car because we are clear we can do it without them. But for the other ones where you have to slow down,
Yeah.
we'll say, you know what, we don't have that model to figure that out. I'll ask your help. So, what I've learned so far is 70% of the things that you do in infra falls into this I can, machine can do it category. So, you don't have to really extend it like building the rods, right? The models that you have is good enough. You just have to build the roads.
Yeah, I,
So,
I think that's a good analogy. And yeah, that's very interesting the way you described it. And that's another topic, right? It is when to, and this is the concept that you're referring to as human in the loop, which is when do you involve a human in the loop? And I think right now, that's another piece that I think is a very good way to launch a product. And this is kind of a standard playbook where you launch a product that automates some type of flow, but then is knows when to flag a human in the loop so that you can launch today. And I think the expectation is over time that percentage will decrease until it eventually gets to zero as we enter, full autonomy when it comes to some of these tasks. So I'm kind of curious in your case,
exactly.
how close are you to getting to zero? Do you see a path there, or do you think that for what you're doing, there will always be some percentage that, you know, needs to flag a human in the loop? So I'm just kind of curious, like what percentage you're at right now and where you see it going.
Yeah. So, this is my looking at the models and the algo strength. Right now, I don't see a way for us to get to 100%.
Hmm.
That's just me being honest. I don't see us getting to 100%. I see us graduating from maybe 80% today or 70% today to 90%. From 90 to 100, I think that ROI will not justify this. Maybe if there is a new generation of GPUs, things will change. As of now, I don't see that happening.
Gotcha. And you don't see it happening because of cost or more because of the intelligence just not being there yet for some of these tasks you're
Mainly
describing?
cost. Because at the end of the day, if you compute enough, you can take any decision and do it. Right. So that's how I see it.
Gotcha. And do you see open source models as reducing the cost to the point where that changes the calculus in your opinion? Or do you think that
No.
even the open source models won't get there?
I think our model mature. It's not the token cost that's a limiting factor. It's the capability of the model itself. The state of the art model itself cannot convert a probabilistic theory into a deterministic action that easily. You have to have another model here that can make this transition. And
Gotcha.
that
Okay.
is an expensive model.
I see. So you're basically saying it's a bit of both, right? It's like kind of this intelligence bottleneck, and then you're saying that when the intelligence gets better, the cost will increase, in your opinion, to the point where it will not be a
Exactly.
clean swap.
Yeah. Maybe the next generation NVIDIA would probably make it happen.
Yeah, it's hard to predict the future.
Exactly. And tell me more about your U.com journey. How do you like it? And what is the transition?
Yeah, I mean, I mentioned a little bit at the beginning, but we started in 2020, and when we started as an alternative to Google. The reason we started was, we saw that there was a lot of innovation happening in AI, specifically around natural language processing. So at that time, I was actually in grad school at Stanford, where I was focusing on natural language processing in the context of healthcare. Um, and that's when I had met Richard, our founder and CEO, and decided that this would be a good time to take the bet and work on applying natural language processing to an interesting problem, which is search. In my opinion, at the time, I thought that natural language processing or search was one of the most interesting applications of natural language processing, and I still think that today. I still think that there's a lot of really interesting work happening. And obviously natural language processing has become, somewhat absorbed by foundation models at this point. So there's
Yep.
not that much, specific work on linguistics as there was in the past. And it's a much broader field where the foundation models have really subsumed a lot of natural language processing research. But that's what we started off in 2020, is this idea of, can we use a lot of these newer models to do something new when it comes to search? And then, the world changed a lot from 2020 to now. When the first LLM came out, we were very quick to ship an experience, one of the first experiences that bridged LLMs to search. And this was kind of one of our experiences called UChat, where we brought search to consumers in a new way. And then more recently, what we realized is, as we've been working on various iterations of our product, the one common foundation has always been information retrieval and search. Initially we were building search for humans. We then started building search for LLMs, and we owned that entire stack end to end via a consumer product. And now we've realized that there's a bigger opportunity for us by just taking the search information retrieval technology and exposing that directly to enterprises and businesses, and really democratizing search and information retrieval. So that's kind of that. So that's been our evolution here at U.com. So right now we're really focused on building web search APIs and exposing those to enterprises, and particularly enterprises building agents. These can often take the form of AI native companies, but also bigger, larger, more legacy companies as well that are now moving fast.
Got it. Got it. And on the context side of things, right? So when you, especially somebody is starts using LLM, they figure out, you know what, there is some magic there. Now, the hard reality, can we put some context around it? They realize, you know what, context is probably a lot more powerful. The tools and the data is a lot more significant than the foundational model. So, what is your general philosophy on how to adopt using an LLM? When you start using a foundational model, you get married to it, you go deep into it, you leave your infrastructure aside, you do some orchestration, you get stuff moving. Later to realize that at scale, this is your limiting factor now. You don't have the right tools, you don't have the right data, and now you cannot move fast, right? So how do a new company that is trying to adopt it go after it?
And when you say try to adopt it, you mean trying to adopt a lot of these foundation models and build new experiences using
Agents.
intelligence.
Exactly.
Yeah. Yeah. So, I mean, it comes down to just being really intentional in the design of the product and what your agent is trying to do. So, I think that, for example, an agent that's trying to do a very general task. So, let's say a generic chatbot that just answers any question in the world. That would probably be a very tough product to build, given that the foundation models are designed to do this essentially, and they have these very general capabilities. So that's an example on one extreme, of an agent being a little bit too general, unless you're the foundation model provider itself, in my opinion, to fully differentiate on. The other side of the spectrum is you choose a really specific problem and you automate it using agents, but it's so specific and it's so constrained, it's not really useful to anybody. So it's definitely easy to kind of lean too far on the direction on other side of the spectrum. And I view this spectrum as somewhat what I would call like a generality spectrum, where you have hyper vertical applications and agents, and then you have very general agents. I think most successful agents probably operate somewhere in the middle, where you're
Mhm.
providing true value to a customer, but you're also providing differentiated value compared to just using the foundation model in its most bare capabilities. So I think a lot of it comes down to just being very intentional about the problem that you're choosing. And I think having this product sense is more important than ever right now. So really having a sense of, what are the pain points right now when it comes to using certain types of agents, and like where would an agent really help, where you just can't you can't get this benefit from uh, foundation model directly right now. So I think, yeah, I don't know if there's any substitute for having really good product sense in this day and age.
And probably think about the 28 models too when you start building something.
Yeah, and I think that's also what I factor into product sense, is building something, knowing that the models are going to get better, and ideally the product will get better itself. So I often think, when you're building an agent, it's worth doing a thought exercise and thinking about, what if these models became perfect? Like, what if they really were able to answer any question, given the information and inputs, that they've been provided? Then what you probably realize is it's really important to focus on giving the model the right context. and the right data, and maybe having some type of flywheel where you can keep improving the agent, with new sources of information that are not accessible to foundation models trained on the public web and maybe private web as well.
Yeah, we can probably call it durability test or something like that.
Yeah, I think it's probably worth a stress test, I guess, whenever you're building an agent, is how durable will this agent be?
Yeah, yeah, perfect. Hey, Sahil, so the other question, since you're from search, you're focusing on search, right? How's search different for agents versus humans? Search for agents versus search for humans.
Yeah, this is a good question. And I think that we have a very unique perspective here because we're building search for agents right now. And we also build search for humans as well. So we've seen firsthand the many differences that it comes down to. At the end of the day, many of the principles are still the same. In both cases, when we're talking about search for humans and search for agents, we're trying to provide high quality information to some type of customer or user or actor, whether it's a human or an agent. The differences are in terms of how these actors process information. So when it comes to humans, what we noticed is, humans are very focused on the ordering of results. So precision really matters. So precision at top k equals 5 is important because humans generally look at the first couple results and they often don't look at the results at the bottom, and they certainly don't go to the second page of results. So that's the 10 blue link world, where ordering really matters when it comes to humans. Agents, on the other hand, can process information, much larger sets of information, so that when they're given information, for example, 10 results, 20 results, they're actually, processing all of it at once. They're not necessarily only looking at the first couple results. There are some, there's some research done on lost in the middle phenomena and all this type of stuff, but it's changing very rapidly as the agents get better, as the underlying foundation models get better and better. So that's one difference, is what I would call how we process information. Another difference is latency. So for many use cases, humans are really susceptible and really sensitive to latency. Agents, on the other hand, may be willing to wait a bit longer depending on the workflow, if it's an online workflow. And in that case, we work on a lot of research flows. So that's a second difference, is what I would call like psychological differences, where agents have very different psychological profiles than humans. And a third one is just how we search. Humans can only do one search at a time. I don't think I've never seen a human do 10 searches per second. Whereas agents, on the other hand, can really parallelize and do 10 to 100 searches per second. So when designing search for agents, we should assume that they're able to really parallelize and do many searches at once, which has different cost, infrastructure, latency considerations. And that's just a couple. And there's also kind of how you measure performance when it comes to humans and agents is very different as well. So those are just a kind of a sneak peek of some of the differences when it comes to designing search for humans and search for agents. And at the end of the day, the foundation is somewhat similar. You're still building an index, you're still focusing a lot on the raw ingredients, high quality information, but a lot of how you're exposing it and what you're optimizing for is different when it comes to agents versus humans. And that's, the big opportunity ahead of us. We predict that there's going to be more agents doing search than humans soon. I think already Cloudflare published a statistic that showed that there's more HTML pages being requested by agents or models than humans. And this trend is only going to continue.
Thank you, Sahil, for coming and talking to us about your one idea. It was fun. We learned how to build an agent the right way.
Yeah, thanks. It was really fun having me. Thank you so much for inviting me, and really nice to meet you.
This is One Idea. I'm Suresh Mathew. If you like the show, please subscribe and put your comments, put your one idea in the comments, and we will call you to host you on the show. Thanks again.